Hello, this is Mike Cherry. This is the electrical diffusion experiment, diffusion electrical system. I have constructed and tested my circuit, which consists of a large charged capacitor charged on a 9-volt battery, and then in parallel we have 8 capacitors of 1000 microfarads. When charged, the circuit completes the program that we saw in the video, and um, one note, initially the circuit didn't work because I had forgotten to take the plastic wrap off the battery. So it's very important. Check all your circuits, place the battery on them, charge it, and the circuit goes through the Gaussian equilibrization. Also, we were asked to calculate the diffusion coefficient. When we write the ODE for the circuit, taking the limit as difference goes to 0, it reduces to 1 over RC, where the resistors are in series and the capacitors are in parallel, and we get a resulting D of 7.4 times 10 to the minus 9. Secondly, we were asked to compute the charge. If we assume this, that energy is conserved, that the charge going from 0 to 9 volts, we have the charge over the capacitance. That integration gives us 1/2 Q squared over C, or 1/2 CV squared, and our resulting equation answer is 3.3 volts. I would like to take a moment and talk about the course. The essential part or lesson I take back is that everything is similar regarding modeling engineering systems. And to that end, I like to bring up a reference that I found regarding Twitter. In other words, does the messages across Twitter diffuse with the same distribution? And you can see from this paper, whose link I will provide in my work, this paper was done by, and we can see the circuit equation looks very similar to the ones that we used. The same conservation laws. So modeling information diffusion in online social networks also can use partial differential equations. And again, I'll add this reference to, or this link to my submission. Additionally, so modeling information diffusion on social networks with the partial differential equations. My point on this is that the same type of mathematics and same type of modeling can be used to as cited in this paper. And as we can see, the circuit diagram is even similar. And then finally, we can see the mathematics, and I'll pause here and read it, that the action results from the relevance of the content of information rather than the structure of the Fowler graph of a network. In general, the information flows from high density to low density, and therefore a simple expression of flux J can be J equals negative D, a diffusion coefficient, of the information over the distance, which results from a principle analogous to Fick's law in biology and physics. Lastly, what I'd like to do is talk about the history and the science. This paper is a German paper, Hero and Highlights in the History of Diffusion. It's a German author, and again, I'll put the citation link in. But I mean, it's important to realize what we owe the people who developed this. First of all, Adolf Fick was a physician, inspired by the inventor, or rather the discoverer of Brownian motion, Thomas Graham. But many decades later, Albert Einstein related the mean square displacement of atoms to the diffusion coefficient. So we've gone from the Brownian motion of cells to the movement of atoms, all using the same model. So thank you very much. This is Mike Cherry.